All right, the rest of this unit is looking at reaction types, and this is our first set of types, combination and decomposition. And with the reaction types, with all of them except for decomposition, I'm going to ask you to predict the products. I do this for several reasons. One, I think it's just a good way of understanding what's going on in a reaction. But secondly, it's really good practice for your nomenclature skills. Can you figure out what the formula needs to be and write the formula correctly? So it's just good review of that skill as well. All right, so combination reactions, we'll start there. As the name implies, it's when you combine things. So you're going to take two elements or compounds, we're going to combine them to make one thing. Okay? The general form is A plus B goes to C. Okay? They're really easy to spot because they're the only type of reaction that has one product. Okay? So you take A and B, combine them together, you get C. That's a combination reaction. So predicting the product is pretty simple. I'm not going to give you any covalent ones because they can be, different ratios. Like if I gave you carbon and oxygen, it'd be like, well, is it carbon monoxide or carbon dioxide? Actually, in reality, it would depend on how much oxygen is present. But I'm going to give you, most common type I'm going to give you is this, a metal plus a non-metal. And so you just figure out their ionic charges and then write the formula. Notice, it has nothing to do, we're not simply combining what's over here. We're not going to say MgS8. No. Magnesium is 2 plus, sulfur is 2 minus, and we get this formula. It may be helpful to write like 2 plus above here, 2 minus above here, so that you can figure out what the formula would be. Then you would need to balance this. I put an 8 here, give me 8 sulfurs, and then I'd have to put an 8 here to balance that out. So 8 magnesium plus S8 gives me 8 MgS, okay, if I were to balance it out. All right, same thing with the next one. Oxygen is 2 minus, potassium is 1 plus, so my formula is K2O. Using those ionic charges again. Once again, it is not related to the quantities over here. Okay, it is related to the ionic charges. That's what gives you your final formula. Okay, then finally SrCl2. That one just happens to work out just right. Okay, so then you need to go back and balance them. However, you need to do that with the counting. As you get more and more comfortable with balancing, you can kind of do the counting in your head without having to write it out underneath the equation. So if you're getting comfortable with it and you don't feel like you need to write out count it underneath the reaction, then don't. I do it by looking at it. I'm like, all right, KO2, so I need 2 of these to balance the oxygen. That gives me 4 potassiums, put a 4 there. I kind of do the counting in my head instead of having to write it out. But if you're not there yet, that's okay. If you need to write it out underneath and count it out underneath, that's fine. If that's what you need to do. Whatever you need to do to get the right answer, go with it. Okay? But if you can do it kind of counting in your head, that would be awesome. All right, so that's combination reactions. Pretty simple. Key thing, one product. Next thing, the product is determined by ionic charges. And then you need to balance them out. All right, decomposition reactions. As it implies, is when decomposing. You break something up into 2 or more parts. Okay, it's the only one with a single reactant. Okay, and so that's how we identify a decomposition reaction. There are patterns for this, and there are rules, but it's beyond the scope of my mind for a general chem course. To me, it's more of an AP Chem or a college chem topic, but some of the rules just so you see them, and this is where, like we talked about with in balancing, carbonate likes to get broken up. So carbonate gets broken into carbon dioxide, and the oxygen stays here, here, once again the oxygen comes off. Here's hydrogen peroxide. This is what happens when you put it on a cut. It forms water, and then those bubbles are oxygen gas. And that's what's going on there. And there are rules that govern these, but we're not really going to worry about it. Okay, so predicting products is one of the things I'm asking you to do. I am also asking you to identify reaction types. So I'm going to give you reactions, and you're just going to have to look at them and tell me what type they are just by looking at them. Once again, I just think this is a good skill to have. and it helps you kind of understand what's going on chemically. So combinations have one product, reactants have one reactant. So just looking at these, which one's a combination reaction? This one, okay, because it has one product. That's the combination reaction. The decomposition reaction is this first one. It has only one reactant, so it's decomposition. This one is something else, which we'll learn later. Okay, so you would say neither or other for that one. Okay, so go through your workbook, practice identifying and predicting the product for combination reactions, and then I will see you in the next lesson.